Part A of this one, they give us the little slope field. So you're just meant to kind of trace that and then just make sure it goes through that 0.04. So they got that dot in there. So just kind of trace that shape a little bit. Part A is done. Notice they give us a derivative and then they're going to eventually ask us for the original function, this h. So eventually it'll be a nice little differential equation problem here. So here's all the work and all the answers for this one. Part B. Let's be careful here. It does tell us h of t is greater than 1. So I wasn't quite sure how I was going to use that yet, but I figured that'll be important at some point. And then it says find the value of t between 0 and 5 where h has a critical point. So remember, a critical point, that's gonna involve taking the derivative and setting that equal to 0. And they gave us the derivative right here. So for part B, I'm gonna try to find this critical point. I took my derivative. I'm trying to figure out where this is equal to 0. Now, normally when you have an expression like this where you're multiplying two things, you're going to say, hey, this is equal to 0 where h is equal to 1 and also where that cosine is equal to 0. But because, remember, they told us h of t was bigger than 1, so that's always bigger than 1. That's never equal to 1. So that portion of it is never going to go to 0. And so I'm only concerned, I just know now this derivative is equal to 0 wherever this cosine is equal to 0. So remember on your unit circle where your cosine is 0, that's like where your x value is 0. So that's normally like pi over 2, 3 pi over 2, 5 pi over 2, and so on. So remember when you have a weird angle, you just first look at where the cosine is equal to 0. So on that unit circle where the x value is 0, so that's the pi over 2, 3 pi over 2, and 5 pi over 2. And if you have a weird angle, just take whatever that weird angle is and set it equal to that. This was a no calculator problem. And then to get the t by itself, just multiply everything by 2. So I got a bunch of those values, but remember our interval is between 0 and 5. And so that the pi is about 3.14, and then that's 3 times 3 something, and then 5 times 3 something. So those are going to be too big right there for us. So t equals pi is the critical point. So just setting that derivative is equal to 0, solving that, getting t equals pi, that's our critical point. And then after you find that t equals pi, it says at that particular point, determine whether you have a relative min, relative max, or neither at this value right there. So what I did, this is my first derivative. I kind of made a little x, y prime chart to figure out, I just want to test the derivative. So there's my pi. We just said the derivative is equal to 0 there. So I'm taking like test points to the left and to the right of that and plugging it into this first derivative. Now, the nice thing is the 1/2 is always positive. The h minus 1 part, they told us h was bigger than 1, so that part is always positive. And then so I really just need to plug into this cosine of t over 2 right there. So whether I plug in 0 or pi over 6, something to the left of pi, that's going to be like pi over 6 divided by 2, which is pi over 12, which is still going to be cosine of a quadrant 1 angle. So it's going to keep that thing positive. And then if I plug in like 7 pi over 6, if I go 7 pi over 6 divided by 2, I mean, that's going to take us from a quadrant 3 to a quadrant 2. Even if I did like a 3 pi over 2 and I plugged it in there and made it 3 pi over 4, it would take it into quadrant 2. But regardless, quadrant 2 and quadrant 3, the cosine is negative in quadrant 2, quadrant 3 from your all students take calculus there. So that part of it is negative. And since that first derivative changes sign from plus to minus, that means your function went from increasing to decreasing. So that would make that a relative max right there. So you got to just stress like the chart, you don't technically need the chart. You just need to check something to the left and to the right of that. But what you need to stress though is that, hey, there's a relative max at that t equals pi. Since the derivative changes from positive to negative, it will be a relative min if the derivative changed from negative to positive. And if the derivative did not change sign, it would be neither. All right, and then letter C. I really love these problems there. This is going to be a good strength of ours. It says use separation of variables, find the particular solution to the differential equation. So we know that, we've seen that a bunch. That's when you're going to get the y, separate your variables, get the y's with the dy, x's with the dx, integrate both sides, remember your plus c, and then use that point that they give you, that initial condition they give you to plug it in to figure out the c value, and then solve that like for the y variable typically. So on this one, I'm going to start with that first derivative. I'm gonna move the H's over with the DH, all the extra stuff in the T's I'll leave over there with the DT. And then so I have H's with DH, T's with the DT. Now I'm gonna integrate each part of that. So that's gonna be an ln. That I gotta be careful with the balancing. That is a UDU. Balance that 1/2 with the 2, and then they'll cancel out. And then the integral cosine is gonna give us sine. So you separate your variables, integrate both sides. And then you got to remember that plus C. So we always stick that plus C on the side the X's are on. And then what I like to do right here is plug in the initial condition, that 0, 4, plug the 4 in for the H, plug the 0 in for the T, and then figure out what that C value is. And then I can plug that back in. And then I want to solve this for the H. And if we want to get that nice answer that's always on that AP rubric, if you have a couple ln's on one side, move them all together on one side, use your pre-calc properties to condense that logarithm, and then you can use your main definition of the log, go e to that equals that, and then multiply by 3, move the 1 over, and then you got your h of t is equal to this guy right here. So typically you'll get, I think this particular one was a 5-point problem just for letter C. And you get a point if you're separating your variables, a point for each of the integrals. Like if you did one right and missed one, like you get a point for that integral, a point for that integral, another point for finding the C value, and then another point for finding that H value. Puffy ball, like those puffy balls that are on top of like a winter hat.